Hello, grade 10s. Today we're going to start chemistry. Okay, since we're going to start, we're going to talk about organic chemistry, which is a branch of chemistry that actually studies the structure, properties, reactions of organic compounds which actually contain carbon equivalent bonding. So it actually determines their chemical composition and formula. Okay, and it's not just carbon, it's actually carbon and hydrogen. It's more likely as hydrocarbons. Okay, let's get started. The first thing that you have here is the fuel. Fuels here could be like coal, could be natural gas, could be petroleum. Natural gas, which is mainly consistent of methane. Petroleum is actually a mixture of hydrocarbons, which can be separated into fractions. The uses of petroleum fraction here. We've got the refinery gas, the one that we use for heating or cooking. We've got the naphtha fraction, we've got gasoline, we've got kerosene, paraffin fraction, diesel. All these are sort of petroleum fractions. Okay. The first thing that we go through here after the fuels is the compounds that make the organic chemistry or the organic compounds. We've got the alkene, we've got the alkane, the alcohol, the carboxylic acid, and the esters. As you can see over here, that anything ends with an ane is actually referred to the alkane. Anything ends with an ene goes with an alkene. The ones that end with an ol, like ethanol, methanol, it's actually an alcohol. Oic acid, like benzoic, methanoic acid, it goes for carboxylic acid, and alorate goes for ester. The first thing that we're going to start here with alkanes. The general formula for alkanes is carbon with an N, that it could be like 2, could be 4, 3, it depends here on the structure that we have. Hydrogen, 2N plus 2. So let's say that instead of the N we've got 2. So it will be C2H2 multiplied by 2 plus 2. So it will be C2H6. Here, what do we have? C2H6. Here, ethane. We've got 2 carbon, and on each side it bonds with 3 hydrogen here and a single bond here with the carbon. So what differs the alkanes from the alkenes is the bond, because in the alkenes between the first and the second, or it could be the second and the third carbon, there will be a double bond. But here in the alkane, it's only a single bond, as you can see over here. Also here in the methane, we've got the carbon here and 4 atoms of hydrogen. Propane, C3H, 1, 2, 3, 4, 5, 6, 7, 8. So the final formula for the propane is actually C3H8. Each carbon atoms in alkene has 4 covalent single bonds. This makes them quite unreactive. Okay, we come here to something, or actually it's a chemical reaction, which we call a combustion. The combustion is all about burning in the presence of oxygen. You have to have enough oxygen. But the combustion has 2 kinds. It's either a full combustion with the presence of enough amount of oxygen, or incomplete, that means we have not enough oxygen to be burned them clearly. So the complete combustion here is that we have enough oxygen supply, so water and carbon dioxide form. For an example, methane is a part of a gas. So when we burn it in the presence of enough oxygen, we will have carbon dioxide and water as a product from this chemical reaction. Meanwhile, in the incomplete, is not enough oxygen to burn them. cleanly. So either carbon monoxide, which is a toxic gas, and water, or carbon and water forms. So it's either with insufficient amount of oxygen, we will have carbon monoxide, or carbon alone with water. The chlorine substitution is sunlight or light is necessary. A chlorine atom replaces the hydrogen atom. This happens to all hydrogen atom if there is enough chlorine. Like for an example, here we've got methane with chlorine. In the presence of light, we would have these compounds. Okay, if like for an example we would have, for the compound here is chloromethane, di, tri, tetra, it depends on how many atoms do I have. If it's like 2, I would call them di, if it's 3, tri, if it's 4, tetra. Alkenes, the general formula for the alkenes is CnH2n. The functional group here is a double bond between the 2 carbon atoms. For an example here, the ethene. The ethene, look over here. Previously in the alkane we had a single bond between the 2 carbon atoms, but here no, we have a double bond. This minimizes the attachment of the carbon, since the carbon has 4 edges or 4 free atoms to bind with another atom. But since it's like 2 over here are taking, so 2 are left to be bound with 2 hydrogen atoms in order to give me C2H4. As for here propene, we will have 1, 2, 3. We can just take the number out by using the general formula. If I have n equals 3, so I would have C3H6, which is 3 multiplied by 2. I will have them over here, which I have 3 over here hydrogen and 3 over here, and these are 6 with 3 carbon atoms. Okay. Okay, now it's kind of like a differentiation between the saturated hydrocarbons and the unsaturated hydrocarbons. The saturated hydrocarbons have no double bonds. Meanwhile, the unsaturated have double bonds, like the alkene. The saturated don't react with aqueous bromine, so the mixture stays orange. Meanwhile, the unsaturated reacts with aqueous bromine, turning it into a colorless solution. Addition polymerization. What is a polymer? It's actually a long chain of carbon made up of monomer units. The polyethene, for an example, is a polymer produced from ethene by addition polymerization, continuous addition. Okay, the alkenes addition reaction. We've got them in details in your book, so practically we're just going to go through them. When the alkene reacts with bromine, for an example, we've got ethene with a bromine, it forms the first the 1 and 2 dibromine ethene. You have the ethene, but in the first and second carbon you would have, instead of a hydrogen, you would have bromine. And also with the steam, it forms alcohol with heat and pressure and a catalyst, like ethene with steam H2O, it actually forms ethanol. With hydrogen, a double bond breaks down to form an alkane. So practically when you want to reverse like an alkene into an alkane, add hydrogen to double bond so it can break down the double bond. For an example, ethene, when you add hydrogen, it gives you ethane. Alcohols, the general formula is CnH2n plus 1 OH. For an example, methane is CH4 as an alkane. Okay, instead of the 4th hydrogen here, we replaced it by an OH group, so practically we had it here as a methanol. Okay, the fermentation and catalytic addition of steam to ethene. The fermentation enzymes in yeast break down glucose to ethanol and carbon dioxide, giving out heat. And it can be done with substance that contains cellulose, starch, or glucose. And it's done by grinding source, like for an example, grapes, and adding enzymes to break down the cellulose and starch into glucose. We leave it to ferment, and fractional distillation takes place to get the ethanol out of the mixture. As a catalytic addition of steam into ethene, it's actually obtained by cracking long chains from oil. The ethene reacts with the steam, and a catalyst like phosphoric acid, low temperature gives a better yield, but high temperature is used to give a better rate of reaction. The advantages of fermentation and disadvantages. As an advantage of fermentation, it's actually a renewable source and good use of waste organic material. Meanwhile, the disadvantage, the bad thing about it, it's like lots of material needed, so big tanks are needed, and also fractional distillation is a bit expensive, and it takes it's like time consuming. It's like it takes time, and it's a slow process. The advantage, it's like when you take it from ethene, is fast and it continuous process, and pure ethanol takes out and smaller container. But the bad thing is like oil is non-renewable resource and a lot of energy to make steam and get right conditions, and a lot of ethene is unreacted and then recycled. Ethanol, since it's an alcohol, it burns well in oxygen, giving out plenty of heat, as well as carbon dioxide and water. And ethanol, we use it as a solvent to dissolve things than water cannot, and evaporates easily, so they use it in glues, printing inks, and perfumes, and as a fuel to add it or instead of petrol, because it burns cleanly. The last thing here is about carboxylic acids. The general formula is CnH2n plus 1. Till here it's the similar of the alcohol, but the carboxyl, the group of carboxyl is the COOH. So here, methane, it's CH4, right? But look here, the COOH over here is actually what the carboxylic group, and since I've got left one hydrogen, so it's methanic acid. Ethanol, it's C2H4 or C2H6, as we took it in alkene and alkan, but here, look over here, the COOH, this is the carboxylic group, and what is left of the ethane is CH3. The properties of ethanic acid, it's a weak acid with high pH and low dissociation, formed by oxidation of ethanol and with acidified potassium magnate. The carboxylic acids react with alcohols to give esters. So when you want to take an ester, or you want to form an ester, you take carboxylic acids, to react with, okay. So you take in carboxylic acids to react with alcohols in a condensation reaction. For an example, we've got ethanoic acid and ethanol. It's a reversible here. This is the sign of a reversible reaction. Ethyl ethanoate and water. And that will be the chemistry for grade 10. Thank you for listening.